2. What we're going to do is we're going to use some of these proofs and we're going to apply them to quadrilaterals. And again, we have these note pages that we want to keep in mind. So I usually start this lesson by asking kids to describe themselves, and usually kids find it pretty difficult to describe themselves, which is ironic because, like, who knows more about you than you, right? Should be pretty simple, but they don't have a plan, and that's really the point of these pages, is to have a plan to do a proof, right? Like if you go to an interview and you know that they're going to ask you to describe yourself, you have some confidence to be able to answer that question because you've already thought about it a little bit, right? You have a little commercial for yourself, who you are, what your name is, where you grew up, what you like, what you don't like, right? So now you have this confidence. It's the same thing. If we go through these steps of a proof, we should have a little bit of a confidence of what they're going to ask us, and we should be able to respond accordingly. So if we look here, it says, Carla knows that a parallelogram has 2 pairs of parallel sides. She has studied special properties of isosceles triangles and right triangles, and she wonders if parallelograms also have special properties. She remembers that it is possible to create a quadrilateral that looks like a parallelogram by rotating a triangle about the midpoint of one of its sides. Carefully trace the triangle at right onto tracing paper. Be sure to copy the angle markings as well. Then rotate the triangle about a midpoint of a side to make a quadrilateral that looks like a parallelogram. Is Carla's quadrilateral truly a parallelogram? Use the angles to convince your teammates that the opposite sides must be parallel. Then write a convincing argument. What else can the congruent triangles tell you about the properties of the parallelogram? Look for relationships between the angles and the sides of a parallelogram. So let me go ahead and set all this up. Basically what it's telling us to do is sort of extend this thing. I got the wrong color there. Let me go a straight line tool anyway, make this a little bit easier on all of us. So if we draw this parallelogram, hopefully we agree this angle goes up here, this angle goes here, and this angle is going to come down here. And the question is this thing a parallelogram? Well, if we look at the definition of a parallelogram, what we're going to see, and by the way, I think this is really handy, this definitions, right? A parallelogram is a quadrilateral with 2 pairs of parallel sides. So one thing before we move on I want to point out here, I would definitely go to your note page and I would definitely start to fill out these shape definitions. I would even draw pictures of the shapes, right? So you can easily draw a parallelogram here, but put the exact definition, because we're going to be using these definitions throughout the entire chapter. So sometimes they're going to tell us the shape, and if they tell us, hey, look, it's a rhombus, now we know that we have 4 congruent sides. Or if that doesn't mean the opposite sides are parallel, anything about the angles, a rhombus means that we have 4 congruent sides. And vice versa, if they ask us to prove that something is a square, we need to prove that we have 4 right angles and 4 congruent sides. So that's what we have to prove a square. So I think it's good to have these definitions written down and handy and available. So they're telling us, is this a parallelogram? And we need to have 2 pairs of parallel sides. Well, if I look at this, I think it's pretty obvious that I have 2 pairs of parallel sides, because look what I have here. I have alternate interior angles that are congruent. That means that these sides are parallel. And these are alternate interior angles that are congruent. That means that these sides are parallel. So again, a couple of points to make here. One, that if we go back to our note pages, we've used the definition of parallelogram, but not only that, but we've also used alternate interior angles. And furthermore, if we go to our proof note page, we know that anytime we have parallel lines, we should be looking for angles, and anytime we have angles, we should be looking for parallel lines. Well, that's just what happened right here, right? We knew these angles were going to result in these being parallel lines. So there we go. We have 2 sets of parallel lines. So I would argue that indeed we do have congruent triangles. I'm sorry, a parallelogram, my mistake. I'm kind of jumping ahead a little bit. So it says, what else can congruent triangles tell you about the properties of parallelograms? Look for relationships between the angles and sides of a parallelogram. At this point, I usually try and change this a little bit. Like, we're talking about the same thing, but I want to begin to introduce these proofs. So I am going to give us this. I'm going to tell us that ABCD is a parallelogram, and I'm going to ask you to prove 2 things in turn. First, I want you to prove that ABD is congruent to CDB. And then after we're done proving that, I want to prove that BC is congruent to AD and that AB is congruent to CD. So a lot going on here. So I'm going to go through my proof steps. First, I'm going to start with a given, and I'm going to end with what it is I'm trying to prove. So I'm going to start with the given. I know that ABCD is a parallelogram. And I know that because they told me that. That is a given. And I know at some point I'm going to try and prove part A, the triangle ABD is congruent to triangle CDB. I just don't know exactly how I'm going to prove that yet, right? So going through, I'm gonna go back to my plan, right? So I've already done the first thing. I've started with the given and I'm ending with the proof. Now, the given may become evidence later in the proof. So let's take a look here. They've given me that it's a parallelogram. Is that going to become useful later in the proof? Well, again, another thing is we know that our shapes and definitions of those shapes are important. So we've already learned that a parallelogram means that it has two pairs of parallel sides. So because of all of this, I can now come back and I can say, hey, look, I'm going to say that AD is parallel to BC. This D doesn't look very good. And I'm going to say AB is parallel to DC. And why do I get to say that? I get to say that because that's the definition of a parallelogram. So two things happen there. Parallelogram. Two things happen there. One, I was able to use the fact that the given became evidence later, and two, the shapes help me determine that. So if I go here, again, this became evidence later, and that definition of the shape allowed me to fill this in. Hey, now look what I have. I have parallel lines, so that's going to be another thing I'm looking for. Anytime I have parallel lines, I'm looking for angle relationships. So what angle relationships do I have here? Hey, these are alternate interior angles, and they have to be congruent. And these are alternate interior angles, and they have to be congruent. So I'm going to say angle ABD. Ugh, jeez, so bad. Angle ABD is congruent to CDB. And I'm going to say angle ADB is congruent to angle CBD. And I can say both of those are true because if lines are parallel, then alternate interior angles are congruent. Now, you might remember at the beginning of video 1, I told that story out of order, and I said it's nice to have these stories in order because it makes more sense. These proofs need to be in order because it makes more sense. The first thing we knew is it was a parallelogram, and because it was a parallelogram, I could say the opposite sides are parallel, right? And since the opposite sides are parallel, I can say these alternate interior angles are congruent. So this follows in a logical order. I wouldn't want to go out of order there. Now I'm going to keep going. I'm going to say DB is congruent to DB. And I know that's true because reflexive sides. I don't even need to say sides, it's just reflexive property, right? And again, let's look at our notes here. We can fill in the reflexive property. Something is equal to itself. So I would fill in these notes. That's a good example of the reflexive property. We've used given, we've used alternate interior angles, we've used reflexive property already in just this one problem. And again, we used definition of a parallelogram in this problem. And now I'm going to go back to my note page. Actually, I'm not going to go to my note page. I'm going to go here because look what I've proven. I have proven that DB is congruent to DB So now I have angle, side, angle, angle, side, angle. I can say, this is my step 5, ABD, triangle ABD is congruent to triangle CBD. I know that because of angle, side, angle congruence. So that's the first thing I wanted to prove. All of this is part A, right? I have proven triangle congruence because of angle, side, angle. Now, part B is asking me to prove that BC is congruent to AD and AB is congruent to CD. Well, let's go back to these notes, and I want to point something out here. It doesn't always work this way, but I did start with the given and end with the proof. I did use the given may become evidence later. I did use the definition of a parallelogram. I did have parallel lines give me congruent triangles, and now triangle congruence and corresponding parts of congruent triangles are congruent, work together. I proved that these triangles are congruent. So now I can come back and say that the parts are also congruent. Now let's think about this. Everything in black is what I proved. I'm trying to prove in red that I'm trying to prove that BC is congruent to AD, and I'm trying to prove that AB is congruent to CD. I haven't proven that at all yet, but since I've proven these triangles are congruent, I can come back and say that the parts are also congruent. So I'm already done, right? I proved triangle congruence, so now I can say the parts are also congruent. I can say, hey, by the way, BC is congruent to AD, and AB is congruent to CD because of CPCTC. The congruent triangles, right? These congruent triangles, that means the parts are also congruent. I proved this angle, this side, and this angle, this angle, this side, and this angle, but this opposite side is also congruent, and this opposite side is also congruent. That's what these corresponding parts of these congruent triangles are also congruent. So I've proven part A and part B. Now, if I go to the next problem, it says definitions are, I'm sorry, here. So I sort of combined 7.1 and 7.2 together here. So it says definitions are one of the building blocks of geometric proofs. For example, by definition, a parallelogram is a quadrilateral with two pairs of parallel sides. You can use the definition of a parallelogram or another polygon as a starting point for proving other properties. So does the diagonal of a parallelogram always split the quadrilateral into two congruent triangles? So we proved that it did, right? It says draw the diagram at your right, and what do you know must be true from the definition. Mark the diagram appropriately, and then write a flowchart to show the triangles are congruent. So we proved those triangles are congruent, and then we extended the flowchart proof to prove the opposite sides of the parallelogram are congruent. We did all of that here. So I jumped a little bit ahead on that, but I'm not going to redo this video again. I've already messed this video up like 3 times already, so that was a mess up right there, but I'm going to live with it. So this ended up being 7-2. I'm a little bit disappointed in myself, but whatever. So I went out of order. I'm going to be fine. So if we jump to 7.3, it says Kip is confused. He put the two triangles together like this, but he does not get a parallelogram. So what transformation did Kip use? This looks like a kite. And it says, see the definitions in the polygon, the math notes, which we've already looked at. And a kite is a quadrilateral with two distinct pairs of consecutive congruent sides. And there we go, right? These are congruent. So this whole bottom side is congruent to this whole top side. So we have angle, angle, side congruence, or angle, side, angle congruence. Either way, congruent triangles. So definitely have those there. So now I'm going to go ahead and set up the next proof here. So I've sort of taken what we have here and made up my own proof with it. We're going to try and prove. We're going to be told that ABCD is a kite, and we're going to be asked to prove, first of all, that angle B is congruent to angle D. And then once we prove that, we'll be asked to prove that AC bisects BAD. So let's kind of go through that. So again, the first thing we're going to do is we're going to say that A, B, C, D is a kite. We're going to start with our given, and we're going to end with what we're trying to prove. So I know that somewhere down here, I'm going to say angle B is congruent to angle D. I just don't know how I'm going to do that yet, right? So kind of go through here on our notes, see which one of these apply. Remember, maybe they will, maybe they won't. Last one they all applied, they don't always. So first of all, start with the given, end with the proof. I already did that. The given may become evidence later, and know your shapes and definitions. And I'd say these two go together again, just like they did in the last problem. I need to know what a kite is. So a kite is a quadrilateral with two distinct pairs of consecutive congruent sides. So I'm going to say, all right, well, I know that AD is congruent to AB and DC is congruent to BC, right? That's what I get to say there. I get to say AD is congruent to AB, and I also get to say that DC is congruent to BC, because that's the definition of a kite. I get those congruent sides there. Next one's a little bit tricky. I'm actually going to draw a line AC. I'm allowed to do that. I get to say, hey, look, I want to make this line right here. And the reason why I get to do that is because 2 points connect in a line segment. Honestly, you could just say something like a line segment. That'd be fine. All right, now that I have that, I'm going to say AC is congruent to AC. And I know that because it's the reflexive property. And now look at that. I think I can say these triangles are congruent. So I'll say triangle ADC is congruent to triangle ABC because of side congruence. So if I go back to my note pages, you can see the given became evidence later, and I needed to know what a kite, the definition of a kite. There are no parallel lines here, so this one didn't really do much for me. But here we go. I proved triangles are congruent. Now that I proved the triangles congruent, I'm probably going to use CP/CTC. So look, these triangles are congruent. Have I said anything about these angles at all? Have I said anything about angle B and angle D? I haven't. But because these triangles are congruent, then the parts are congruent. So this must be step 6. And step 6, I'll say CP/CTC. And again, you can see how triangle congruence and CP/CTC go together. So that's part A. So let's go ahead and jump into part B. Now I want to say that AC bisects angle BAD. Well, what does it mean to bisect something? And again, if we look at our note page, this is going to be kind of important down here. We have bisect an angle. And to bisect an angle or to bisect anything, bi means 2. It means we're going to cut it in half, right? So I need to say that I cut this angle in half. Well, the easiest way to say that I cut an angle in half is if I have 2 halves. So what if I go here and I say, all right, well, angle DAC is congruent to angle BAC. And I'm hoping you guys know why. Right? Why can I say angle DAC is congruent to angle BAC? Well, let's look. It's just like step 6. I've already proven these triangles are congruent. Now I'm going back because the side. So I've proven all the sides are the same, but I haven't proven the angles are the same. But because the corresponding parts of congruent triangles are congruent, so corresponding parts of congruent triangles are congruent. And then, hey, look, these halves got cut in half, so now I can finish by saying AC bisects angle BAD. I can say that because that's what the definition of a bisector is. If you tell me something got bisected, If you tell me this angle got bisected, I'll tell you the halves are equal. If you tell me these angles are equal, I can tell you that angle got bisected. So it's really the order. And again, would strongly recommend you guys having that thing filled in, this note page filled in for these, like our plan here, but also our evidence stuff, right? We want to drives me nuts. Okay, so we have this evidence stuff, right? We know what a kite is. We know what a parallelogram is. We know what given means, what alternate interior angles are. We know what reflexive sides are. We know what a bisected angle is. It means it was an angle that it was cut in half. So we have all these things ready to go. This chapter just ends by talking about like what this process of like exploring conjectures proves. So you look at something, you kind of mess around with it, then you say, hey, I think this might be true, then you go about proving it. That's really the process that we're using here. And that is where we're going to end with this lesson.